present your screen or?
Yep. Okay. All right. So, hi everyone. I'm Andrew. I work at Facebook, along with my colleague Corentin. We're going to be chatting a little bit today about the JSL profiling API, some recent updates, and some improvements to the API that we think are interesting and worth discussing. So cool. I'm going to start up with a little bit of a recap as to where we are right now, and what the API is for those who aren't really too familiar. So the JSL profiling API is a web-exposed sampling profiler for measuring client JavaScript. Think of the DevTools profiler, except on the web. This is intended to provide more representative samples of JavaScript execution on real user devices versus dev machines, which tend to be biased in various ways, from employee only script, or they're significantly beefier than the average device in the field and don't really capture the long tails of performance. But yes, so the API was shipped in Chrome 94, and you can see more information over at the GitHub repo. Here's just a very quick walkthrough of how the API is generally used. You can spin up a new profiler, basically for the duration of an interaction, record samples, and when it comes time, for instance, say when the document load event is fired, you can send over the trace, possibly with compression streams if you're feeling adventurous, over to your server for analysis. Basically, the server can perform various trace aggregation, and the idea is to let the developers of the site that is orchestrating the profiling get a better idea of what's actually slow on clients' machines. The API is intended to be used in combination with the performance timeline. Each shares a time origin, and the server can also perform cross-correlation by sending over information such as long task entries, event timing, as well as navigation and resource data. Cool. Here's just a very quick overview of the trace format. We use a very similar format to Chrome tracing and SpiderMonkey, in that we use a trie to represent JavaScript frames. These are all structurally compressed by deduplicating resources, frames, and substacks. I'll be posting the slides as well after, if folks are interested in diving in. But yeah, so what's working well with this API so far? I mentioned that we've shipped in Chrome 94, and we, Facebook, as well as some other large properties, have gotten some pretty good signal as to how the API can be used effectively. One of our big takeaways was that we're happy to confirm the hypothesis that the sampling profiler didn't introduce an unmanageable performance overhead. We were seeing around the 1% line for our top line visually complete metrics, which is pretty good evidence that profiling can be implemented to a modestly large cohort of users without too much overhead. One of the strengths of the API that we're seeing is that it's a very drop-in solution for a lot of client teams to focus more on perf, and in general make perf more accessible. But by providing easy tracing without needs for local repros or endless debugging. And we've also seen strong adoption from other industry partners, such as Microsoft, as Noam discussed earlier in the call. But as with most things, we can be doing better here. We found some pitfalls and gaps in the JSL profiling API as it stands right now, in particular related to non-JS execution. So in the interest of getting a focus on client JS, we omitted in the initial version of the API any top-level UA work reporting. This has been an issue discussed in many contexts for attribution for events like GC, layout, style, and paint. And it's difficult because in the current version of the API, it is indistinguishable from simple idle execution. And so you may end up with many cases where a synchronous GC is triggered, or synchronous restyle, and you won't really have too much visibility into this. And additionally, asynchronous rendering work is also not something that is exposed by the API. So traces currently will not capture like additional work, except with use of the long tasks API in addition that may be scheduled. And yes, as I mentioned, the API does integrate well with long tasks in that you can cross correlate on the server, but the interaction is still quite cumbersome. And that performance overhead of even though it's only 1%, we don't want to be enabling the profiler at all page loads, but we still might want to figure out if we get a bad sample why a long task was slow. Long task attribution has also been discussed pretty extensively in the working group. But for now, I'm going to hand things off to Corentin, who's going to be walking through some of our ideas to chat about embedder state or user agent state for profiling.
Right, thank you, Andrew. So yeah, this part is probably going to feel like a repeat for all the folks who've seen the recent presentation to the group. But yeah, so for the next slide, please, Andrew. Yeah, so to solve the issues highlighted by Andrew, we'd like to propose an update to the specification to add a way to tag the sample captured by the profiler with the top-level work performed by the user agent. So the idea would be to highlight a category of work performed by the user agent at the time a sample was captured. So really here, the goal is to bring us closer to the capabilities of profilers available in typical dev tool today that you get in the browser, where the event can be categorized in different types, such as scripting, rendering, GC activity, etc. So on the next slide, we focus on what could be the marker candidates. So the main issue here for us is interoperability, where we want a marker to have the same meaning across traces and user agents. We are very interested in feedback and proposal as to what would be the most relevant and safe to surface in that area. So for example, typically the scripting tag is an easy one. So we could even argue that this could be optional. The simple fact that you get a stack ID in a sample could be enough to assume that you are running JavaScript. A more interesting one could be the garbage collection event, which could represent a pause that happened when we capture the sample. We could also consider a parser marker to highlight the time we spent parsing the JavaScript or the HTML. Now, on the rendering side, things are a bit more difficult to spec, as currently the event loop processing model only gives us a way to spec the entire rendering pipeline. So we could imagine a general paint marker that aggregates style, layout, and paint. However, it could be very useful to be able to split those markers into, just style, layout, and paint. There are work in progress efforts to try to add those steps into the event loop processing model. On the next slide, we show, that one is very simple. We simply, it's the modification we do to the IDL for profiler sample, where on the last line, we add an optional string to represent a marker. And on the next slide, we show what it could look like in an actual trace. So here you have an example of a garbage collection event that is interpreted as JavaScript on the left side, and that you can properly identify it on the right side. So that way you're able to cut through the noise that would be added by a garbage collection event. Or like Andrew mentioned before, you could highlight during the what would appear as idle stage currently. You could highlight rendering events. But most importantly, for the security and privacy concerns, so we have to be very careful not to expose work performed on a cross-origin document, meaning that a top-level user agent work may only appear in a trace if the responsible document has the same origin as a profiler. And with this new source of information, there is potential to introduce a new source of side channel information. We haven't gotten security feedback yet on what is safe to share. And there are some concerns, for example, for events that cannot be directly attributed to an origin, such as a garbage collection event. And in such a scenario, we could consider requesting cross-origin isolations to surface or attach the marker to a sample. Right, so since our last presentation, we started the tag review. The initial comments we received, of course, revolve around the security aspect of the feature. And we have published an intent to prototype for Blink, and we'd like to target an origin trial for Chrome 98. So to summarize the open questions that we have, we are still looking into the split of categories that would be the most useful and safe to surface. And yeah, so from our perspective, the garbage collection events are really useful, but they present the challenge of being hard to isolate by origin. And finally, it is worth considering whether or not that kind of data would be more relevant into the performance timeline API. So that is for the embedded state of the interaction. A follow-up to this extension that we'd like to discuss is how we could potentially leverage the JavaScript self-profiling API to make the long task API more actionable. So in the V1, the long task API provide a mechanism to provide attribution to the responsible iframe location URL, but it's typically hard to attribute the cost of a long task to a specific script or a function. So there is current discussion around the V2 implementation that targets at improving the long task attribution. But for today, we'd like to explore whether or not the GS self-profiling API could be a good candidate to help with attribution. So one obvious approach could be, and that doesn't require any specification work, could be to run the GS self-profile API in parallel to a long task observer. And so by cross-correlating the recording sample, you'd be able to attribute to a specific script or function the source of a long task. And yeah, and if you consider the embedded state extension, you also get the classification of work for free. You'd be able to know whether or not you actually spend time doing script or rendering. But this approach main drawback is that it can be quite expensive to run. So it requires the web developers to record all the samples to being able to correlate it with a long task that has been observed. So this approach is going to increase the memory and CPU pressure and is more intrusive than the long task API alone. So we are wondering if somehow we could limit a sample to when a long task is detected. So in theory, no active sampler would be necessary to start capturing a sample when a long task is detected. So for example, currently the GS self-profiling API requires a document policy header to enable the feature. And that could hint the user agents to eagerly maintain code map and metadata without actively sampling on the main thread. That would make the resources available immediately for a sample when a long task is detected. But so this approach assumes that we are able to proactively detect a long task as it is happening. And this is the main challenge. Potentially, we could schedule a background task when we start processing a task on the main thread to capture a sample 50 milliseconds after the start of the task. And so, yeah, that is highlighted on the next slide, where the approach is to being able to capture a single sample 50 milliseconds later or after the start of a task. And so, yeah, regarding the security aspect, oh, sorry, yeah, I skipped the IDL modification. We just attach an existing profiler trace to the observer event. So regarding the security aspect of it, we need to make sure we don't expose attribution cross origins. On the sampling side specifically, the existing cross origin checks will continue to make this safe. So we are really interested in feedback for this proposal. We hope it would help improve the long task attribution and troubleshooting. So we have a couple of questions already. So we hinted at it during the presentation, but how should we enable the feature? We're thinking that the simple presence of the JS self-profiling document policy header could be enough to start attaching samples to a long task when it is detected. This proposal suggests capturing a single sample when a long task is detected, and that may or may not be enough. We could take the approach, like this is a best effort approach, hoping to capture the long-running script or function. And finally, the last question is the cost of it all. Like we're wondering if this proactive long task detection may or may not be more expensive than simply running the profiler in parallel, since it comes with additional work on the main thread to start this task monitoring. Yeah, thank you.
Okay. Yeah, let me stop the recording.